Okay, so we're going to go over a video tutorial on how to do alignment practice 2. So the first part of alignment practice 2 wants you to do a pairwise alignment using BLAST using test 1 and test 2 protein sequences. And I have those pulled up right here. So the first thing you want to do is go to the BLAST homepage. From there you want to go to Global Align. And this is where you'll put in your 2 sequences. So here's test sequence 1. In the FASTA format, test sequence 2, and then we can check back and see if we need to do anything else, but it looks like all we need to do is just use the Global Align program. From there, we'll click the box to show results in a new window and align. And you can see here on the score from the alignment of our 2 sequences, -43 with only 17% identity. You can look at other parts with the graphic summary or the alignments, which will give you more detail onto where the alignments specifically are. So the next part is we need to use the FASTA database search. And that's going to be on this EBI website right here. And we're going to test sequence 1 to limit to structure uniprot KB PDB database. So that's going to be right here. So first, with the structure KB PDB database is found right here underneath structures with the database right here. And make sure you've taken everything else off because this one is not the standard database that's selected when you're on the website. And so we're going to do test sequence 1 here only for this part. So we're going to put it in. We're not going to change any parameters here. And we will submit our job. And here's all of the output that we get here. And so our top hit with 100% identity, it's going to be our test 1 protein in Bacillus subtilis, like we already knew test 1 was. And so it's just a confirmation to say that we are using the right test protein. But you can see through here that we're getting similar proteins but in different organisms. So the second best hit is actually in Vibrio cholera, serotype 01. The next one we get here, I won't even try saying, but it's a different organism. And as you go on, Enterococcus faecalis, you're going to get more and more organisms, but they're going to be the same protein if you look at this. So then the next thing we need to do is run a PRSS to check whether there's any statistically significant similarities between test sequence 1 and 2. So we're going to go to the PRSS webpage, we're going to paste our sequences in our FASTA format, leave everything default, run it, and then we're going to look at the output and find if there's any critical statistical parameters. So here's our PRSS. Put in test sequence 1. Put in sequence 2. We won't change any of the parameters. And we're going to run. Here's our output, and here's our best score. So this is the best chunk of sequence that aligned. And so this is at 224 base pairs. You have this Smith-Waterman score of 91 with a E of 2.2 e to the -6. And so this is our statistically significant sequence. And so that's saying that these sequences line up the best and that it wasn't just by chance, probably, that the sequence lined up. But you can see here that the it's still not great, but it's good based on this percent identity, but you still have 58% similar. All right, and then the final part, what we want to do is find the paper with this PMID, read it, see which paper cite it, and see how that helps us interpret our similarities between test 1, test 2, and determine if we think it's biologically relevant. So in PubMed, I have the PubMed ID already pasted in here. We're just going to search. It's going to take you directly to the paper. And so when you want to see who cited this paper, right here on this side, you have a cited by tab. You're going to click that. It's been cited by 23 different articles, so we can see all of them here. And we can start going through. And you can see that, GTP cyclohydrolase 1, but this is in rickettsia, so it's looking at the same protein but in another organism. You can see with E. coli, you're going to find different organisms here for all of these papers, really, to show that this Plasmodium falciparum, GTP cyclohydrolase 1. And so rather than reading through all these papers individually right now, we'll go back just to answer this to say that the similarity between test 1 and test 2 likely is somewhat biologically relevant. It looks like they're orthologs, and so they're similar proteins, but they have diverged into other organisms, though it looks like their function is relatively the same. So I would say that there is some biological relevance between test 1 and test 2 here. And so that's it with this tutorial for alignment practice 2. Thank you.